Hello, IB Physics. Ms. Getz here. I wanted to do a quick overview of what we had going on in week 7 via video so that I wouldn't have to take class time to do this because you don't need to listen to me talk at you in class. That's something you can listen to on a video, like now. Great. So to start off with in week 7, you're doing a quick discussion post. There's no right answer. I made up the premise, but it's trying to apply the idea of precision and accuracy to real life. So don't stress over it. Just post your thinking really quick, less than 5 minutes. Then 7.2 is writing your rubber band conclusion. To be able to do this, you are going to need your rubber band best fit line. And so this is working on figuring out from your Desmos graph the minimum and maximum best fit lines, and then determining the average best fit equation from those. And if you're feeling at all overwhelmed with this, please reach out to me so that I can help you with it. It's really much easier than you're feeling like it is. It just looks complicated and stressful, and there's like a lot of basic math outlined in the summer homework part that feels overwhelming if you are having trouble tracking what is happening. So if you need help, feel free to reach out. I've got my normal office hours. I'd be happy to help you with it. But once you have your line of best fit, then you're going to be writing your conclusion for your rubber band lab. And I have the directions here in 7.2. You're going to write this in your lab notebook. So I'd like you to have your lab notebook be a nice record of the labs that you are doing so that you can look back at them as we move forward in IB Physics and help you sort of consolidate your understanding. So here you want to have a sketch of your graph. A sketch does not mean a precise drawing. Spend no more than like 3 minutes on it. It's a sketch that should show what's on the axes, the two numbers, 0 to whatever the graph axis goes to. So on the x-axis, it might go 0 to like 300 grams or something. That's it. And then your min-max lines. So it really should not be complicated. And then also you'll want to write down your best fit line. So that's going to be this best fit equation here. And you'll want to have that written down in your lab notebook. So then you're going to need to answer some conclusion questions. We'll get a little bit more into more complex ideas about conclusions later. But to start off with, I'd like you to consider what's the meaning of the slope and the y-intercept in this equation. In physics, every single thing in an equation has some type of meaning, something that it can tell us about the physical situation that we're looking at. And so we talked a little bit in class about this, and you want to go ahead and describe what is the slope telling you about your rubber band, what is the y-intercept telling you about our rubber band setup. Then you're going to get into your random error and systematic error, and for those you're going to again be needing to use this average best fit equation to quantify them. With our random error, we'll be looking at the slope. With our systematic error, we'll be looking at the y-intercept. And then you're going to want to actually predict how far you think the rubber band will stretch with 200 pennies hung from it. So that means you'll need to determine the mass of 200 pennies. And then you'll just put that mass into this equation and determine what it predicts. You'll also want to try to determine then what's your uncertainty in that prediction. So if you predict that it will stretch 10 centimeters, it's 10 plus or minus how many centimeters. So that when we actually do the testing in class on Thursday, you have a good sense of what your prediction is and what the range of acceptable values is for your prediction. Because if you predict 10 centimeters plus or minus 5 centimeters, well, that's a big range of values, anywhere from 5 to 15 centimeters. So the uncertainty is really helpful in giving you a sense for how precise your prediction is. And then we'll actually be able to test the accuracy on Thursday. Then you're going to take a picture of this section of your lab notebook. And if this is not right, if the propagation of error, it's okay. Just upload it, roll with it. It's cool. We'll talk more about that on Thursday as well. So then you're going to upload that here in a picture and try to make your picture nice and easy to read, like with good lighting and so on, so that I can read it reasonably easily. So that's 7.2. 7.3 is actually just the summer homework review page. That's the last page of the summer assignment. I actually suggested that you did that along the way. So if you did do that along the way, good for you. You can just upload pictures of the back and front of it. Otherwise, you should do that. It's a really, really useful review to help you think about like what are all these different concepts. Then 7.4, I have a vocab review, and you can really spend as much time as you want on this. I think I have it set to like games matching. Oh, it's set to matching. So if you want to change study mode, I don't care. It's up to you. But I tried to make a little set here of all of our different ideas. So you want to say, okay, well, I know an independent variable is the variable that is manipulated, the variable whose effect is being studied. Yes, okay. There's, I think, 20 words, so you'll want to do it a little bit, but again, spend kind of however much time is going to be useful for you. I suggested 10 minutes, whatever is useful for you, I don't care. But I thought it might be helpful to sort of get your vocabulary words a little bit clarified and spend a little time studying them, because in 7.5, you're going to be applying these vocabulary words. So 7.5 is a test that is a hands-on test. And it is a summative test, so that means that it's going to be in the 75% category of your grade, which is a large part of your grade. It is due October 25th. Most of the time in IB Physics, I'm very flexible with due dates, but this exam I need you to turn in by October 25th so that I have time to grade it, because it's going to take me some time to do that. And I want you to be able to have the opportunity to reassess if you need to before the quarter ends. And we have a pretty tight turnaround on that. This is week 7, so I need this finished by the end of week 7 so that I can actually grade these and get them back to you before our quarter ends. So what you'll find when you download it is, I think 5 pages. 4 of them are test. The first page is pretty boring. It is a little instructions page and an honor code. You are welcome to use any textbook resources or web resources that we have used, or even web resources that we haven't used, to help you with this. But I would like you to work by yourself. So if you have questions, feel free to ask me. You can come to office hours, you can email me, but I would prefer that you are working by yourself on this test. This part here is for grading. You don't have to do anything with it. If you're curious about my grading scale, I use a standards-based grading scale that, again, it's real easy in IB Physics to pass. But it's a little bit more challenging to pass with like an A. So you don't need to stress about that, but it's there for your future reference. So as you go through the exam, I have some directions for things that I'd like you to measure. And then you're going to be reporting your answers with uncertainties. You're going to be describing how you're getting these uncertainties. The little boxes on the left you can ignore. Those are for me to give you a score. I think these are going to be pretty straightforward. We're measuring some pennies. You're measuring yourself. You're using a leaf to collect some repeated measurements by dropping the leaf first from your waist height while standing and then head height while standing. I don't actually care about what height you're dropping it from, but you'll want to have it be a consistent height. So then I'm scoring those the trials that you collect here based on your sig figs, whether your sig figs match as they should, your average calculation, your statistical uncertainty, and your error bars. And then the last one is a little weird. It's kind of a reflection question, but I will actually be giving it I'll be giving it a score. So this is a reflection question on how you're feeling about significant figures, and the score that you get here is going to say, do your significant figures make sense in all of your problems? So I am scoring significant figures twice, which is a little bit weird, but I do want to make sure that you sort of understand the idea of sig figs and how to apply them to measurements that you take in real life, because that's what they're really, really useful for. As usual, if you have any questions on this, feel free to email me, office hours, etc. If you get stuck, really do that. You're doing your best shot you possibly can, but it should take you about an hour in total. If you're spending a lot more than an hour on this, please reach out to me so that I can help you get things sorted a little bit, see what you're confused by. Okay, so that is week 7, and this has been a long overview video. I hope you watched it in fast forward time. And let me know if you have any questions. Feel free to drop by office hours, and keep up the hard work. See ya.